going to start a lab. It'll be a couple days for the lab, but we need to get started on it today. All right. So just to kind of remind ourselves, based on the data that we graphed when we had, what were the three cities that we graphed? Do you remember? Cheyenne, Des Moines, and San Francisco, right? Those were the three cities that we graphed, and we saw different patterns. Do you remember the two pieces of data that we graphed for each of those cities? Precipitation and temperature. Those are the two big factors that indicate, please put it away so I don't see it. Thank you so much. I should not have to say that every day, by the way. Those are the two big factors that lead to a climate, right? It's not just how warm or cold something is. It's not just how wet or dry something is. But if you put those two pieces together, that tells us a lot about what the climate's going to look like. So we finished up all of the temperature stuff, and we started precipitation yesterday, talking about prevailing winds. This was at the very end of the day yesterday, and I know that we were kind of like ready to move, so I just want to make sure this is making sense to you. Air is a good absorber of water, which means that not only can it transmit temperature or transmit heat, it can also bring water to an area or not, depending on the area that it's around. We know this really, really well in Iowa. The air in Iowa right now, does it have a lot of water in it? No. It does not. What evidence do you have as not only a scientist, but as just a human being living in Iowa? What evidence do you have that the air does not have a lot of water in it right now? What's that? It's a little hard to breathe, right? Yeah, absolutely. What else? That's a good one. I like that. Yes, that was what I was thinking of. I have to use lotion a whole lot more in the winter, right, than I do in the summer. And that's not true of but a lot of people have a lot drier skin. You have to do lots of chapstick in the winter. Whereas in the summer, what is the air like in the summer besides being warmer? It is humid, right? It is humid and sticky. And sometimes, like when it's in like the really hot part of the summer, like end of July, early August, sometimes it feels like you're walking through like a fog. Do you know what I'm saying? Like it's just thick and yucky out there, right? So that warm air holds a lot of moisture, and that moisture then helps to impact precipitation as well. We know that from our water cycle from last unit. So one thing is the prevailing winds. Do you know which way the wind generally travels across the United States?
It's either west to east or east to west.
It's either east to west or west to east.
East to west. West to east.
It's generally west to east. Generally, the air moves, the wind travels from west to east. My family has kind of a joke because we ride RAGBRAI every year at the end of July, and generally the wind is out of the west pushing east, which is nice because on RAGBRAI, you guys know what RAGBRAI is, right? It's a big bike ride. We go right all across the way across the state, and we start on the western side of the state. We ride east, and so that's great if you've got a wind that's pushing you to the east, right? A nice tailwind. It makes it a lot easier to bike. But inevitably, every year it feels like, and maybe it's really not every year, and maybe it's not every day of every week of RAGBRAI, but inevitably there's always a change in the wind, and it pushes the other way, so we get a really obnoxious headwind, which makes it a lot harder to bike when you're, riding 60 miles a day, right? So, but in general, the prevailing wind on the continental United States goes from west to east, okay? That's why if you've ever kind of watched, like weather patterns develop, generally they get things in like the Rocky Mountains area and in Nebraska, and then it comes over and then we get it. And then like the day after we get a really nasty storm, that's when the East Coast gets it, right? Because it travels from us over to them. So that's the same kind of deal. That's the same kind of deal that we kind of showed here, that we're looking at the continent of Africa in this case. Okay. We know that up here is the what? A desert, right? A big desert. What's that desert called? Sahara Desert, yeah? Yeah, another little geography infused into our earth science today. Air from land is really dry. That air from land comes in. That makes sense that if you've got dry air, you're going to have something more like a desert. Whereas here, we have this really nice wind that comes in from the ocean, right? Lots of water, picks it up. And then over in this part of the continent of Africa, it's a lot warmer, it's a lot more tropical, okay? And so that's, or I should say it's a lot more tropical, it's warmer up here, but yeah, more tropical, more humid down there. So prevailing winds is one thing, latitude and ocean currents is another. We're going to write this one down. So this should not be a surprise to you, but we're going to write it down because that's what we do, okay? Water by the equator. Anybody want to give a guess as to the temperature of the water near the equator?
Pretty warm.
Probably warm, right? Whereas water near the poles, what are we going to guess? What do we know? Because we're, smart kids here, right? It's cooler. It's cold. Yeah. The warm water has more energy from the sun. Okay? That warm water receives more energy from the sun. Okay? Warmer water is more likely to allow evaporation. And more evaporation means more precipitation, yeah? So it's going to be humid air that leads to precipitation. Sorry, I kind of ran out of space there. Conversely, the cold water that's near the poles is cold because it receives less energy from the sun. Okay? And then if we kind of follow the path, the warm water had more energy, the cold water has less energy. What's that going to result in terms of evaporation? Less evaporation because it's colder water. Okay. Less water in the air. And little precipitation. Does that mean that there's no precipitation where it's cold? No, I mean, have you looked at the forecast? Right? But the amount of water that we get, the amount of precipitation is a lot less when it's colder. Make sense? A lot of this is kind of cause and effect stuff that seems, at least to me, pretty straightforward. But if it's not, if it's getting confusing, please let me know. How are we doing? Can I keep cruising or are we still writing? You okay? This one is kind of interesting. I don't know if you guys have talked about this. Did you guys have like a geography class when you were in middle school at all or in junior high? No? Okay. That's where I remember learning about this mostly. That's why I was wondering because I didn't remember. So you'll see here that this says mountain barriers. So we're going to go ahead and draw ourselves a big mountain in the middle of this section of notes. So I'm going to draw myself a mountain. You should do the same. The mountains that I think of when I'm thinking about this stuff, the mountain barriers, I often think about the Rocky Mountains. Now, we talked a little about geography yesterday, but I want to just have you imagine. So we're thinking about the continental United States. So the Rocky Mountains are here. What's to the west of the Rocky Mountains? Like what states are over there to the west of the Rocky Mountains? To the west.
Isn't to the west? Oh.
Which is the left, if we're looking at a map this way. What do we have over there?
Oregon.
Oregon. California, Washington, does that make sense? That kind of that Pacific Northwest and then down to California, right? And just to the west of that, what do we have?
An ocean.
An ocean. So I just want to kind of imagine this. So we've got an ocean, and then we've got some nice flat land, and then we've got the Rocky Mountains. And then, so the Rocky Mountains, that's like Colorado, and, they go up through Montana and whatever, and then they go down, through like Nevada and whatever. But we're just going to like, boom, boom, there we go. And then what's on the other side of Colorado and of the Rocky Mountains? Nebraska. How many of you have ever driven through Nebraska?
It's pretty boring.
It's boring and it's flat. Yeah. So there's going to be more land over here. No, it's way flatter than Iowa. All right. Fun fact. Speaking of RAGBRAI and mountains, fun fact. If you ride your bike or your car or whatever, walk from west to east across the state of Iowa, there is more elevation change than west to east across the state of Colorado. That right across the Rocky Mountains. The funny thing about Colorado, if it's flat, mountain, flat, right? And in Iowa, it's hills and hills and hills and hills and hills and hills. It's really hilly in Iowa. If you don't believe me, come join me for a day or two in the end of July, and you'll realize how darn hilly it is in Iowa. It's beautiful, but it is hilly. All right, here we go. So you've got oceans. Tell me about the air that's over the ocean in general.
It's warm.
It's warmish, right? And it's definitely what else? Wet, right? It's humid, warm air. So we got this nice humid, warm air that comes in and it comes across the land. And that's why, Oregon, Washington, Northern California is kind of, it's like picturesque and perfect, right? So nice and not like hot, but not cold. It's just kind of there. It's temperate, right? Then that humid, warm air runs into what?
Mountain.
Boom, right? It runs into a mountain and the air can't go through the mountain. It's kind of annoying. So what's it going to do? It's like that game you played in preschool, right? Can't go through it. What are you going to do? Gotta go over it, right? Gotta go over it. So let's think about what's going to happen here, friends. As that air comes up and goes over the mountain, what do you think is going to happen to that air? It's going to cool down, isn't it? Yeah. The air cools down. And let's think about that. Can cool air hold as much humidity or hold as much water vapor? It cannot. And so what's going to happen? Where's all that humidity going to go?
It's gonna
Right? So you're going to get lots and lots and lots of precipitation here on this side of the mountain. This side of the mountain. So there's going to be a lot of precipitation. So we say lots of precipitation. Okay? Because we've got condensation. I keep saying this side of the mountain, so let me name that side. They actually have a name for it, and the name is, does anybody know it starts with a W?
west side.
It's not always the west, so that's a good guess. That's super good guess. But the prevailing winds don't always go from west to east, right, in different parts of the world. So they have a more technical term for it. It is called the windward. That's okay. It's one of those that if you've heard it before, you're like, oh yeah. But if you've never heard it before, it's not one that you're just going to come up with, right? It's not obvious. Yep. Windward side. This is the windward side of the mountain. Okay. And then Gracie, I'm not even going to ask you if you know the other one because the other one, you totally wouldn't get. It's not non-windward. But let's talk about what's going to happen over there. So we've got this cool air. So there's going to be cool air that comes up over the mountain and comes this way. And now it's cool. And does it have a lot of humidity in it? No. So you got this cool, dry air that moves up over the mountain, okay? And then that cool, dry air is going to sink, right? Because the cool stuff is going to go down, okay? But it still doesn't have any moisture in it. You with me there? Because where would it get that moisture? It doesn't have an ocean to get it from. And so it's cool and dry. It sinks down, and it basically, let me go back. I'm going to go back up here for just a second here. We have air from dry land. We've got dry air. What's that going to do to the land? It's going to make the land dry also. Yeah. So it's going to sink down. It's going to dry out. Okay. So it's funny. I was on a trip with a good friend of mine who lives out east. Like she grew up in the mountains in upstate New York. And we were on a trip and we were driving out to Colorado, and she was so excited because she was totally making fun of Iowa. Like, there's no mountains here. And we're driving out, right? So you drive through western Iowa, which is hilly, but not like mountainous. And then you drive through Nebraska. No offense if anybody's from Nebraska, but Nebraska that takes forever and it's really flat and really, really dry. And then we cross and we stop to take a picture, right? Now entering Colorado. If you've ever driven that, she was expecting, because in her head, because she's, an East Coast girl, she was expecting that as soon as you hit Colorado, what are you going to see? Mountains. Right? It is just as flat and just as boring and just as dry as Nebraska. Like, there's nothing, no difference, except that there was a sign that said, now entering Colorado. She's like, what is this? The funny part of it was we were driving into Denver, and the clouds were so low because there was so much warm air up here that was condensing. There were clouds all over this. And so, like, going in, she couldn't even see the mountains until the next day. It was kind of sad. She's like, we are not in Colorado. She's like, what are you doing? Like, are you teasing? No. It was legit.
Where did you guys go in Colorado?
We actually were going to Utah. We're just traveling through. Yeah. So, yeah. All right. Oh, I promised Gracie that I'd tell you the name. Sorry, because I forgot you that. This is the windward side. And maybe that makes sense because there's wind coming in. I don't know. This one you're not going to guess unless you know it. So let me tell it to you. It's the leeward side. That was your second guess. Darn it. I can't believe you didn't guess it. Right? I'm sure that comes from something, and probably something very logical, but I don't know what it is. So I'm not going to pretend like I do. Yeah. But I would strongly recommend, not having written the test yet, but I would strongly recommend that you are familiar with those terms, right? So the windward side is where you're going to have all kinds of growth. You're going to have lots and lots of vegetation. And then over on the leeward side, you've got this dry air that dries out the land and basically makes it something near a desert. Okay? And if not a desert, then at least just pretty darn dry. Okay. Life is good? Not two S's, just one. All right. I used to get really confused, but yeah. Double S for dessert. All right, last one. Lake effect snow. Speaking of traveling, has anybody ever traveled during the winter up near Chicago? Have you been to Chicago in the winter? Okay. You don't like Chicago at all, or just in the winter? I mean, that's fine. To each their own. What's that? There you go. There you go. You can work on that. But here's the thing. I mean, Chicago happens to be near a body of water as well. Yeah? What's it next to? Do you know? Lake Michigan. Yeah. One of the Great Lakes, right? Great Michigan. Lake Michigan is right on the eastern side of Chicago city limits. Okay? And the funny thing is about Chicago is that sometimes it will snow like a lot within like a quarter mile of the lake. But then if you go out, like into like the rest of the city or, way out into the western suburbs, there's no snow. And which way did we say that the wind goes? West to east. So doesn't it make sense that if the wind is going west to east, that the western suburbs would get it and then Chicago would get it before it, keeps going east? It would make sense to me. But that silly body of water, right? That Lake Michigan business. It's a body of water, and water allows air to pick up more moisture, right? And so even though the prevailing wind comes from the west to the east, sometimes you get swirling. Remember, I just talked about that. It just gets funny stuff. And when that happens, then that moisture will go onto the land, and they'll get like a foot of snow in the city of Chicago, and outside of the city of Chicago, there's nothing. This also happens like in Ohio along Lake Erie. I have a picture of that actually, I think here. Yeah. Whoa. Okay. This is just like a radar shot. So is this looking okay? Like this is Cleveland here, and then this goes up into New York. Does that make sense? A little Pennsylvania there. So this is a radar image. There is no snow down here, right? Just a little, but like this dark blue is where you're going to get the actual snow. Did you guys like that? Was that the noise that you were reacting to? What? Okay, whatever. It's what I do. All right. But right along the lake, you'll get this crazy snow stuff. Okay. My friend, the one that I was telling you about who didn't believe that we were in Colorado, she actually lives like right here. Okay. And they get like ridiculous amounts of snow. I was talking to her, it was last winter. Last winter was not a bad winter, I don't think, at all. And I was talking to her one time about this time of year, I think, and she said that they had like 4 feet of snow in like one big dump. Right? That's crazy. What's that?
That's why I'm never moving.
But it's not all of the East Coast. That's the thing. Yeah. It's like it's like this is Cleveland, right? If you live like down here, like no problem. It's just right along those lakes. Right along the lakes. They get what they call, literally it's called lake effect snow. And it just has to do with the water.
Do they get out of school a lot?
Well, they also know how to deal with it a lot better. Right? Like the big dump. Yeah. Yeah. So that's not why you should move there. Like if you want to move there, by all means, it's beautiful. It's mountainous. So if that's what you're into, that's great. But I wouldn't move there just to get out of school. Like that seems like a poor choice. Yes. Yeah, you.
So we used to live in a
friends
suburb off of Chicago.
Yeah.
And we would go to school in like Chicago itself.
In the city? Uh-huh.
And there'd be sometimes where school would get canceled for snow and we'd have none.
Yeah.
Because we lived like far away.
Yeah.
Like,
absolutely. Actually, yeah, I was actually just talking to a friend of mine who lives, another friend that lives, they live just outside of Cleveland. And Cleveland is right on the lake. And it's the same thing. Like her husband works in the city and teaches. And they live like here. And she'd be like, there's nothing here. But they would get school canceled for this. Yeah, same kind of deal. Yeah, it's funny. It's just like this super concentrated, funny little precipitation bubbles. I don't know. It's kind of weird. All right, let's write something down about that, shall we? Let's do it. So land near large bodies of water okay, sometimes receive heavy precipitation because, well, let's write down kind of the cause and effect here. Air blowing over land is cold and dry. We're talking about in the winter here, right? Yeah. Yeah. Air hits water. And when it comes into I don't say contact, but when it's near the water, what's going to happen? What does it do? What does air do when it's near like a big body of water?
It absorbs the water.
It absorbs the water? Yeah. It absorbs the water. Even if it's cold, it's still going to absorb water. Yeah. So air hits the water and it absorbs moisture Okay. That air then blows over land while it's got all that moisture in it. Okay. And cools again, which condenses the water in the air and snows a lot. Okay. How are we doing, team? Doing okay?
Yeah.
Sweet. All right. We're done with notes, finally. It only takes like 3 days to do it. Phew. We're done with it. You can put that away, and then would you send one person from each table up to get one of these per person, please? So what's the goal of this lab? First of all, let me actually back up. Is this an actual data collection lab, or is this a simulation? How do you know it's a simulation? Because it's not real what? Yeah, well, it's actually real dirt. I'm going to give you real dirt, but what's in it? We're looking at colored paper, right? Colored paper instead of actual pollen. Why? Why do you think we're doing that? Pollen allergies, good call. Why else? Pollen is really, really little. They do this a lot. Like wildlife biologists and geologists do this, but it's really, really hard. It's really, really careful work, and it's challenging to do. Why are we doing this? What's the purpose of doing this?
Like helps plants grow.
So pollen helps plants grow, sure.
It's a useful.
What did you say? Oh. Why are we looking at pollen in dirt though? What's the purpose? Put that in your own words, David. What did you just say?
You've heard about the climate, the time the pollen was higher.
Yeah, that's absolutely right. If you know what kind of plants were living, then you know what kind of climate was there, right? If you see lots and lots of pine trees, do you think that it's a desert? If you see lots of pine trees, do you think it's a rainforest? No. We're going to start counting pollen first thing tomorrow, okay? I want you to listen carefully, friends. Listen before the bell rings. On the back of this page, there is some reading to do. Listen. If for some reason we do not have school tomorrow, check your email by 9 a.m. and I will send you the reading so that you can do this, okay? We don't have time not to. Bye! I'm not saying, no, I'm saying check it after 9, and then you'll see it.